Hello, week 4. Today I'm going to talk a bit about dividing rectilinear forms using the X marks the spot method. Now, we're talking about finding the middle of shapes. And you may say, well, geez, don't you just measure half of it and measure the other half and find the middle? Well, yeah, that's a way to do it. And when you're not dealing with perspective, when you're dealing with a flat shape, a square, or any shape that's just has no perspective to it. But once you get into perspective, and foreground, background, things get a little wonky because it's drawing and it's art school, and that's what happens. All right. So first, we're in chapter 11 of the book, and this talks about that stuff in a lot of detail, and this is a really interesting chapter. It talks about dividing, which is what we're going to do. Dividing surfaces into unequal space, because that's what we're dealing with. We're dealing with unequal space now. We'll get into this stuff, but read chapter 11. God, chapter 11 is so important. So please read it. Also, there are worksheets in coursework, supplemental work. Week 4 supplemental materials has some sheets for you to take a look at. Please check those out. So I'm just going to give you a real quick version of dividing rectilinear forms. So okay, now that we're getting into some more complex forms, there's going to be times where we're going to need to find the center of things. And there's a scientific, time-tested way to do this without having to get into measurements and numbers or anything. It's kind of magic. Check it out. We're going to connect the corners. Draw a big X on this thing. Now this is a straight square, so these corners are going to connect very equally. This is clearly the center of our square, so that means we've divided it into 4 perfect squares. So this is now exactly half of this whole thing. We go to a rectangle, and this is flat, no perspective, same concept. There's our center, there's our center, center, center. Okay, big deal, Ken. Cool, I knew that when I was like 12. Well, we have to apply the same exact principle when we're dealing with perspective, because if we simply measure this line, and find center mathematically, sure, we're going to find the center of that line, but we're not taking into account diminishment, which is going to distort where the center of this is. So we do the same exact thing. If we draw our X marks the spot, X's by connecting the corners. Damn it. Now we've found center. So you can see how much different the center, or how off center the actual center looks. It's not in the middle of the lines mathematically. It's almost a 2-to-1 ratio, really. Yeah, basically. So now our center And again, these are, your verticals are vertical, so you just carry your vertical up, and that's easy. To find the horizontal center, it's a little different. We know it's going to be around there. But since we haven't drawn an actual horizon, or we're not quite sure where we are on the horizon, we're going to have to wing it a little bit. So we said there. Let's check it. I'm way off. That's there. The middle of that is our center vertically. And this is less scientific than the X marks the spot method, but we don't really need to go into that detail. Well, that's right about dead on. So now we know the center of this plane, the horizontal center of that plane, which looks to be a little bit just below the horizon. See, because it's sloping down. But either way, we have found the exact center of that plane of that box. And this works whether we've got a super long distorted rectangle Believe it or not, that's actually the center of that plane. If this is a wall, and that's, the side of your CCS building, and you're standing here, there's a doorway, and you're here looking up, that's the center of this wall. Even though it's not the center of this line, this works out. And it works with any plane on this shape. Here's the, say, the side of a building. Right? There's center. Here's going to be the center of the roof line, the center of the ground line. You want to do a table or a plane in 1 point perspective. Same thing. X marks the spot. I'm going to go corner to corner on that top plane. Can you see that? Now this is 1 point. So our horizontals remain horizontal. The horizontal center of that plane is right there. And you can see that back half of that plane, that table, let's call it a ping pong table. Alright? That back half is shorter. It's going to appear shorter than the front half because of diminishment. Again, here's just a regular rectangle. Same thing. You've got the center right there. So what, isn't a ping pong table have a line down the center? I don't know. But either way, you found the center. And this box, or this half of this box, is equal to this half of this box. Because we're looking at it flat on, just like that. But either way, X marks the spot to find the center of things. Why? Why are we finding the center? Who cares about the center? If we were going to draw this from scratch, we'd start with that base. Just a 2-point. God, I'm pressing hard. I'm at such a weird angle, like leaning over. I can't do this. I'll try to get around the camera some. Alright, so we would find the base, and now we know that this top half is coming out of the center of this base. So we got to figure out, where would we start this? If we started it mathematically, the center of this line, it's going to appear like it's too far forward. So we go find the center of that side plane, drop a vertical, because verticals stay vertical, and now you've got dead center on that side plane, so you know this is the center of this structure going up. So now you could start to draw that structure now that you've found the center of that bottom box. Why is finding the center? How do we do it up here? Well, yes, this is a triangle, but we need to think of it, first of all, as an additional rectangle. Where are we? I'm going to say the horizon line is just about here. So this would have a little bit of perspective downward toward that vanishing point way out there. So we would make that X, take that perspective. There's a box, like in perspective, just like this. We make our X, which is, I need to sharpen. Corner to corner, find that X. Now we know where center is. Vertical stays vertical. Now we know where the center of that triangle is. Let me show it to you this way. So let's say that's that tower. And this time we're looking at it straight on. So we know there's a triangular shape up here. And it starts about there, so let's call that another rectangle. We would find the center of that rectangle by X marks the spot. Throw that vertical up there. We now have the exact center. What does that give us? That triangle shape. At the top of that spire, or whatever it is. See that? X marks the spot, guys. Center, X, boom.